How do I find prime numbers super fast?
We've taken the clock and we've put it onto a poster board. 1 o'clock, 5 o'clock, 7 o'clock, and 11 o'clock. All the primes are located at these times. The boxes in blue are the composites, and the boxes in yellow are the primes. Using primes 5 and 7, you can quickly locate all primes between 1 and 100. 1 o'clock, 5 o'clock, 7 o'clock, and 11 o'clock. Let's start with the number 5. 5 times 5 is 25. That's at 1 o'clock. What would be the next one in the 5 prime cycle? That would be at 11 o'clock. We're going counterclockwise from 1 o'clock to 11 o'clock. What is the difference between 1 o'clock and 11 o'clock? Well, that's 2. So we add 2 to the multiplier 5, that's plus 2. 5 plus 2 is 7. So we go from 5 times 5 to 5 times 7. So what's the next one in the 5 prime cycle? Well, we're right now at 5 times 7, which is at 11 o'clock. We want to go from 11 o'clock to 7 o'clock. What is the difference between 11 o'clock and 7 o'clock? Well, that's 4. So we want to add 4 to the multiplier, 7. 7 plus 4 is 11. So we go from 5 times 7 to 5 times 11. What's the next one in the 5 prime cycle? Well, right now we're at 7 o'clock and we want to go to 5 o'clock. Going counterclockwise, the difference between 7 o'clock and 5 o'clock is 2. So we want to add 2 to the multiplier 11. 11 plus 2 is 13. So we go from 5 times 11 to 5 times 13. What's the next composite in the 5 prime cycle? Well, right now we're at 5 o'clock. We're going counterclockwise. So to go from 5 o'clock, we want to go to 1 o'clock. What is the difference between 5 o'clock and 1 o'clock? Well, that's a difference of 4. So you want to add 4 to the multiplier, 13. 13 plus 4 is 17. So we go from 5 times 13 to 5 times 17. What's the next composite in the 5 prime cycle? Well, right now, with 5 times 17, we're at 1 o'clock. So we want to go from 1 o'clock counterclockwise. We want to go from 1 o'clock to 11 o'clock. What is the difference counterclockwise from 1 o'clock to 11 o'clock? Well, that's a difference of 2. So we want to go add 2 to the multiplier 17. 17 plus 2 is 19. So we're going from 5 times 17 to 5 times 19. We can see here how we eliminated all of the composites in the 5 prime cycle. So that takes care of 5.
To better understand clock math and how it can help us quickly discover prime numbers, we need to understand how primes exhibit double spin. First of all, primes spin down the number line, creating composites. Secondly, primes exhibit mod 12 spin, meaning that they create composites by spinning counterclockwise or clockwise. This very complex double spin hid the pattern of the primes for centuries. But this pattern is now available for you to see it with your own 2 eyes. If you've never seen a traditional clock, 12 begins at the top, 6 at the bottom, 3 to the right, 9 to the left. Clockwise spin goes like this: 12 to 3 to 6 to 9, back to 12. Here's how the numbers go: 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For counterclockwise spin, we go in the opposite direction. We go from 12 to 9 to 6 to 3, back to 12. So it goes like this: 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, back to 12. Let's take a look at the prime number 5. It exhibits number line spin insofar as in the blue box you see 5 times 5 is 25. The composites are getting larger. 5 times 7 is 35. It continues to spin, where 5 times 11 is equal to 55. Now let's examine mod 12 spin. This is where we see 1 in the purple, 5, 7, and 11 in yellow. 1 o'clock goes to 11 o'clock. That is counterclockwise. 11 o'clock goes to 7 o'clock. That is counterclockwise. That is a mod 12 spin. and the prime number 5 will continue in this fashion, in this counterclockwise fashion, indefinitely until you reach extremely large composites, where nearby you will also find extremely large primes. Let's look at the prime number 7. There are two types of spin. There's spin down the number line, in which 7 is creating composites that are getting larger and larger. We see that in the blue box, where 7 times 7 is 49. And in the next blue box, we see where 7 times 11 is 77. Now we're going to consider mod 12 spin. This is a clockwise spin, in which the number 7, the prime number 7, goes from 1 o'clock to 5 o'clock, then to 7 o'clock. It will go to 11 o'clock and then back to 1 o'clock.
Well, 7 starts in 1 o'clock, 7 times 7. But instead of going counterclockwise like the 5 prime cycle, we're going to go clockwise with the 7 prime cycle. So the first one is 7 times 7. That's at 1 o'clock. If we want to go to 5 o'clock, that's going clockwise. What is the difference between 1 o'clock and 5 o'clock going clockwise? That's a difference of 4. So we take 4 and we add that to 7, the multiplier. 7 plus 4 is 11. So we go from 7 times 7 to 7 times 11. What is the next composite in the 7 prime cycle, going clockwise? Well, right now at 7 times 11, we are at 5 o'clock. We want to go clockwise to 7 o'clock. The difference between 5 o'clock and 7 o'clock is 2. So we take 2 and we add that to 11. So 11 plus 2 is 13. So we go from 7 times 11 to 7 times 13. So now the 7s are eliminated. So with the 5s eliminated and the 7s eliminated, all the composites between 1 and 100, actually between 1 and 107, are eliminated. And every number that remains is a prime. Why is that so? Because every number would be prime if primes did not combine to create the composites.